Hello, class. Good morning. Welcome back again to one more physics class for the chapter number 5, light, from page number 71. So we have started this chapter a couple of weeks back, and till now we know about what is light. We have learned about speed of light, isn't it? Yes. Then we learned about sources of light. So these are all your recalls. Okay, I'm just recalling the topics that we have already discussed, isn't it? So we have learned about point and extended sources of light. Yes, those were natural and man-made sources of light. We also learned about luminous and non-luminous bodies. Yes, these are the things that we have already covered in this chapter, isn't it? Then we did one very important topic in the last class, that was rectilinear propagation of light, which means light travels in a straight line. That was the thing that we have discussed in the last class, isn't it? Apart from this, we also learned about light rays. There were three different beams of light: parallel beam of light, convergent beam of light, and divergent beam of light. So these are the topics that we have covered in this chapter number 5, light. Okay. So today we are now moving to another topic called pinhole camera from page number 75. Now every one of you, please turn your book to page number 75 and get ready with pencil. Understand? So as usual, I've taken the snapshots from your book. Okay, understand? And I will be explaining the topics that you have on your book line by line. So let's go to the topic, that is pinhole camera. So you'll find this topic, pinhole camera, on your book on page number 75. On the same page you'll see this figure also. This is a figure for a pinhole camera. All right, okay, let's begin. Now, what is pinhole camera? A pinhole camera consists of a rectangular metallic box. So you see you have a rectangular metallic box here. So it's a metallic box. It's not necessary that it should be made up of metal. You can even make this out of cardboard also. Okay, you can make it from wood also. It's up to you how you make it. Understand? With a small hole in the metal plate at one end. So here you see a small hole. Here you see a small hole. This hole is called pinhole pinhole. Understand? That is why the name comes pinhole camera. It's a camera with a hole. Okay, and the size of the hole is equivalent to a pin. Okay, like your safety pin, like your all pins, isn't it? So you can see, you can imagine the pin, okay, of that needle, isn't it? Yes. So it's the small hole. It's a very tiny hole. Understand? Tiny hole which is present on the metal sheet. There is a screen of tracing paper or a frosted glass. Okay, tracing paper or a frosted glass on the other side. So this is your the other side of the metallic box is covered or placed with the tracing paper. Now, what is tracing paper and a frosted glass? They are what? Translucent material. What are they? Translucent material, which I'll tell you later. Okay, translucent material. Now for a brief, you can just remember that these are the materials which allows light, okay, to pass through them partially. Only a little amount of light can pass through them. Such materials are called translucent materials, and the examples are tracing paper and frosted glass. Okay, so you might have seen some window pans, okay, a hazy type of window pans, isn't it, through which you cannot see. त्यसबाट देख्दैनौ तर कम्ती लाइट चाहिँ त्यसबाट पास हुन सक्छ त्यस्तोलाई चाहिँ त्यस्तो ग्लासलाई चाहिँ we call it frosted glass. Okay, now if a lighted candle is placed in front of the hole, you can see there is a lighted candle. You can follow the figure from your book. Okay, if you are not able to see here on the screen, an inverted image of the candle is formed on the screen. So here on this screen you will see an inverted image of the candle. Okay, so the image can be seen more clearly if the external light is excluded by covering the head with a dark clothes. If you cover, okay, the external light, okay, by to avoid it to come or to fall on it by a dark cloth, then you will get a brighter image. So since light travels in a straight line, it follows that a given point on the screen will be illuminated by the light coming straight through the pinhole from a certain point of an object, that is candle, outside. So rays of the light from the various parts of the object outside will thus travel in a straight lines through the pinhole from the patches on the screen. So from here you underline. Okay, so light, what is happening, the rays of light from the, okay, various parts of the object outside will what travel in a straight line through a pinhole, okay, and from patches on the screen. So that is how the object is getting an image on the screen. So these patches combine to form an inverted image of the object. A blurred image results if the hole is made much larger than a pinhole. So if this hole is made a larger larger hole is made, what will happen, the image will be blurred. Now see, what is the main motive of learning this camera or learning this pinhole camera? So now main motive of this is to realize, to know that light actually travels in a straight line. Okay, so if you see here, you see that from the tip of the candle a ray is traveling on a straight line and what, striking on the screen. So tuppa candle ko tuppa the ray is traveling and reaching here. Okay, let me change the color here. It's reaching here, understand, and from the base of the candle the light travels in a straight line and reaches here. So that's why you are getting an inverted image, understand. So the main motive of learning about this camera is to see, okay, or to demonstrate, to practically to see that light travels in a straight line path, understood. Okay, now let's see about the size of the image formed by a pinhole camera. So now this, you just follow the book as I read. The size of an image formed in a pinhole camera depends upon the distance of the screen from the pinhole and the distance between the object and the pinhole. So there are two things. Okay, one is the screen, the distance of the screen from the pinhole, that is, this is the screen and this is the pinhole, so this distance, understand, and the other one is your what, the distance between the hole and the object. Are you getting my point? Yes. Okay, so let me explain you here again. See the size of the image. Okay, suppose say this is your pinhole camera. Okay, so here you have the screen, here you have the pinhole, okay, and here was our candle, which was the object. See, so first one is this distance from the pinhole to the candle, that is object. Other one is the distance from the pinhole to the screen. So two distance, you can write d1 and d2. So size, okay, of the image, कत्रो इमेज त बनिन्छ, ठुलो बनिन्छ कि सानो बनिन्छ यहाँ इमेज. So that image depends upon these two distances. One is the d1, that is distance from the object to the pinhole. Other one is d2, that is the distance from the pinhole to the screen. Understand? So let's see what does it say. The greater the distance of the screen from the pinhole, larger is the size of the image and vice versa. So if this distance from the screen, okay, to the distance to the pinhole, if distance is large, okay, if this distance is large, what will happen, large image will form, understand. And if the distance is less, what happen, smaller smaller object will be smaller image will be formed. Okay, so please underline on the book. Next is the distance between the greater the distance of the object from the pinhole, the smaller is the size of the image, and vice versa. So here is just the opposite. If this distance is larger, what will happen? The size of the image will be smaller. Okay, so distance pinhole र screen को distance ठुलो छ भने चाहिँ you will have a ठुलो image. Okay, but object र pinhole को distance ठुलो छ भने चाहिँ यो तिम्रो image को size चाहिँ what will happen? It will decrease. So this is what how the formation or the size of the image formed by a pinhole camera depends. Understand? Okay, so the next topic that you have is shadow. Okay, shadows. Now before we learn this shadow, we must understand that there are three different types of materials. Three different types of materials. Number one is opaque. Number two is transparent. Okay, and number three is translucent. So as I've already told you about translucent, let's first begin with opaque. Now opaque are those materials or those objects which does not allow light to pass through them. Light चाहिँ तिनीहरुबाट छिर्दैन. For example, school building, the wall, stone, isn't it? Our body. Does our body allow light to pass through us? Light हाम्रो जिउबाट छिर्दैन नि त. So those substances or those materials through which light cannot pass is called opaque. So what do we call to them? We call to them opaque. Now let's go to the next one, transparent. Now you see, from water or through glass, light can easily pass. Light छिर्छ नि त, पानीबाट पनि छिर्छ. That's why you are able to see the fish under the pond through the water, isn't it? You can see through the window pane, through the glass, isn't it? So those materials or those substances which allows light to pass through them is called transparent. Understand? Here transparent. But there are some substances which allows only little light to pass through them. Little light to pass through them. Those substances are called, or materials are called, translucent. What do we call to them? Translucent. For example, butter paper. Okay, butter paper. We can call it tracing paper. Okay, these are substances or materials which allows little light to pass through them. Dulle light te pass garnu दिदैन. Okay, like water and glass. Okay, तर कम्ती लाइट चाहिँ तिनीहरुबाट के गर्न सक्छ? छिर्न सक्छ. Those substances or materials are called translucent. So with this concept, let us now learn shadows. Now you know that the light travels in a straight line. So if an opaque, now see the word opaque has come, object is kept in between a source of light and a screen, the light does not pass through it. Understand? So if there is a body, okay, which is opaque, means this body will not allow light to pass through them. Okay, understand? But you have lighted a candle here, so from the candle light is going to travel how? In a straight line path, isn't it? So here you see that here the light ray is able to pass through it, but at this point light is not able to pass through this body. Understand? So त्यति बेला चाहिँ if I have kept a screen here, this is the area where the light is not reaching because the light has been blocked by this opaque body. Understand? So this dark patch, okay, so the patch of the object on the screen remains unlighted. This unlighted portion is called a shadow. Understand? त्यसलाई चाहिँ भन्छ हामीले shadow. Okay, छाया नेपालीमा भन्छ छाया. So from here you underline the dark patch formed behind an opaque object when kept in a path of light is called shadow of that object. So remember, shadows are formed by opaque object. छाया चाहिँ कसले मात्रै बनाउँदो रहेछ? Opaque objectले. So when we walk in the sunlight, our shadow moves with us. You have experienced this, isn't it? If we stop, our shadow will also stop. If we dance, our shadow will also dance. If we stand facing the sun, our shadow falls behind us. घामपट्टि फर्क्यो भने हाम्रो छाया चाहिँ कहाँ हुन्छ? पछाडि हुन्छ. In the daytime, we see the shadows of trees, buildings, houses, vehicles, animals, people, etc. So shadows are formed by moonlight, candlelight, and electric light, also apart from sun. So घामले मात्रै छाया बनाउँदैन, moonlightले, candlelightले, or the light from the electric bulb also forms shadows. Alright, so I hope now you've understood that shadows are nothing but the dark patch which is formed because light does not reach there. Light चाहिँ त्यहाँ पुग्दैन किनकि opaque object is what? Obstructing or stopping the light. Understand? Because you know light cannot pass through the opaque object. Alright, okay. Now, how is shadow formed? So as I have already explained you how is the shadow formed. So a shadow is formed when something like an opaque object comes in the way of light. Usually shadows are formed on the opposite sides of the source of light. So source of light यहाँ छ, यसको ठीक opposite मा चाहिँ के form हुन्छ? Shadow. Understand? So here you have a picture also on your page number 76 ma. If you see, okay, figure number 5.10, you will see this formation of shadow. So for the formation of shadow of an opaque object, a source of light and a screen are needed. You can form your own shadow. For this, switch on a table lamp. So here you have a table lamp and stand in the way of the light. So you are standing here in the way of a light. The dark patch behind you is your shadow. So this is your what? Shadow. So you might have observed that the length of the shadow formed by the sunlight changes with time. कोही बेला लामो shadow form हुन्छ, कोही बेला छोटो shadow, isn't it? So the shadow is very long in the morning. Yes. As the day progresses, the shadow becomes shorter. So when is the shadow shorter? In the daytime. Okay. The shadow is shorter at the noon. Okay. And when sun is directly overhead, the shadow is what? Directly under you. The shadow once again becomes longer in the afternoon and it's longest in the evening. So longest or very long shadow कति बेला हुँदो रहेछ? One is in the morning. Okay, morning. Other one is in the evening. So morning and evening you have your shadow which is longest. Okay, in the daytime what happens? The shadow becomes short. Okay, at noon टक्कै दिउँसोको 12 बजी it becomes the shortest. Okay, so shadow becomes shortest when? At the noon. So this kind of questions I may give you in the exams. So please know or take a note of this kind of explanations. Alright, so this is how shadows are formed. Alright, so that's it for today. Thank you.